So here is our second lesson. So first thing we're going to go over are a few changes here that I made for PID. So for PID, what we did is we added a velocity PID controller. So here we have the RPM 435, the CPR, which is the counts per revolution. So that gives you ticks per revolution of the output shaft. You're going to want to use that to track the position of the axle on the motor. And then for max velocity, you do CPR times RPM divided by 60, which gives you ticks per second. That gives you a velocity scale. Okay? And then here, our calculations are for KF, we do 32,767 divided by the max velocity. For KP, we do 0.1 times the KF. For KI, we do 0.1 times KP, and KD is 0. And then we plug that into our PIDF controller. And then voila. And here we have a few added methods: reset PID output, and then also get position. Now here we also have an extended version of the yellow jacket that uses motor X. So you're going to want to do Control B to go up to that definition. And it's an extended motor class that utilizes more features than the regular motor. This is basically a rewrite of DC motor in the basic SDK, but has more features and a more powerful PIDF controller. Okay, and you can do everything you can do with a regular motor here. And again, you can look at this in the uh, link to my repository in the description. And just like that. And then here we have a subsystem. So in our hardware, I've organized to say I have motors in one package, subsystems in another. Okay. And here we implement subsystem, and that has 5 methods: initialize, reset, loop, stop, and disable. That's 6 actually. No, wait, 1, 2, 3, 4, 5. Yeah, 5. Okay. And this is for a command-based system, right? So we can use this subsystem for both autonomous and for Teleon. And so all of the overridden methods are going to mostly be used for autonomous, except for initialize and maybe stop or disable. Other than that, we would use something like loop, which uses PID right here for that. Okay. And again, you can take a look at this in that repository. So let's write a one motor lift together. And of course, subsystem. First thing we're going to do is we're going to write a constructor. And we want an extended yellow jacket. And then here we're going to set the mode to run using the encoder. As you can see, this works exactly the same way as DC motor, but instead of that, we use motor extended. And here, instead of set 0, you can just use stop motor. And there we go. Next thing we want to do is make our teleop method. And here we're going to do a PID write. So we're going to have layer upon layer of PID just to make sure that everything is going smoothly. And we're going to just put power right in there. Alright, so now that we have that, now we can create our op mode for the lesson. Let's call it and we'll do an op mode instead of a linear op mode this time. Annotate as a teleop. Let's say we have a differential drive. Let's go back here because what we already have written we can just reuse. I see we already used on mode last time. Let's use a linear this time, actually. Okay, instead of mechanism drive, we're gonna make this a differential drive. And then we also need a motor group. As said here, to pass multiple motors per side, use a motor group. No need for the IMU. Differential drive doesn't have a field-centric model. Just like that, boom. And then here we create a loop that will loop it here. And then here we're going to have to wait for start. Which is waiting for the play button to be pressed. And then we're going to do an arcade drive with square inputs. And now we're also going to introduce a new thing we can use, which is the extended gamepad. So we're going to call this one the drive controller. And the other one is going to be the mech controller. And here in differential drive, we see that our K drive does Y speed, takes Y speed, and turn speed. And then square inputs, just like that. So then now what we want to do is we want to use, we have to define the drive controller. There we go. And the next thing we want to do is we want to do that. IL for intake left, and then IR for intake right. And this actually takes a yellow jacket 435 input. Just like that. Let's make that a little nicer, just like that. Boom. Alright, so now we have those ready, so now let's get the subsystems. Take right, boom. Take left, and take right. Alright, now, and then once it exits this, we actually want everything to disable. Let's stop the motor there. now everything is disabled right there. Now here I actually forgot to do something, which was I forgot to call initialize in the constructor. Okay, now here we're going to do we'll put this on the mech controller. Right, and that, so now we're checking to see if the left bumper is pressed. We want that to intake. Outtake. Else we want it to stop. Okay. Next we want the lift. This should probably be the mech controller, the drive controller, and just like that, boom. And just like that, we have made a robot with subsystems, and of course this will be available for you to see. So what to take away from this is you have to create the subsystems yourself. Inside of the subsystems, you're going to put the hardware and the methods. And in your op mode, you're going to use gamepad triggers and other things like that to create the different effects. And this is a little bit easier because this is a teleop, but it'll be a lot more difficult for when we get into how to write an autonomous, because in that I'll also teach you odometry and things like that. And as well as that, we also went over PID control, and I also recommend that you take a look at the video on the PID control loop. Now note that there is an error in there, and that is it's not just you're adding KF, you add KF times the set point. So if your set point is 0, then it's going to do KF times 0 so that you get down to 0. So feed forward, actually the feed forward constant is actually multiplied by the set point. So that's the only error in that video. Other than that, it's perfectly logical and makes sense and is accurate. So that's it for this video, and I'll see you in the next lesson.